Download this code from codegive.com, link in the description below. Architecture tests, fixing broken code reviews and ensuring quality. Code reviews are crucial for maintaining code quality, identifying bugs, and ensuring adherence to standards. However, code reviews can become bottlenecks and sometimes fail to catch architectural issues that can cripple a project in the long run. This is where architecture tests come in. This tutorial will guide you through understanding, implementing, and leveraging architecture tests to improve your code reviews and overall software quality. Why code reviews fail to catch architectural issues. Traditional code reviews primarily focus on code style, adherence to coding conventions, readability, and formatting. Functionality, correctness of the implementation, edge cases, and expected behavior. Logic, efficient algorithms, optimal data structures, and clear control flow. Security, vulnerabilities, potential exploits, and compliance with security best practices. While essential, these aspects often miss critical architectural flaws, such as dependency violations, unintended dependencies between modules, violating layered architectures. Cyclic dependencies, modules depending on each other, leading to tight coupling and fragility. God classes / objects, overly large classes with responsibilities that should be distributed. Feature envy, methods accessing data from other objects more than their own. Violations of design principles, lack of adherence to solid principles, single responsibility, open/closed, Liskov substitution, interface segregation, dependency inversion, dry, don't repeat yourself, and other architectural patterns. Why architecture tests are essential. Architecture tests automate the verification of architectural constraints, providing the following benefits. Early detection, identify architectural violations early in the development life cycle, preventing them from becoming ingrained in the code base. Automated verification, automate the verification process, reducing the reliance on manual code reviews to catch architectural issues. Consistency, enforce architectural standards consistently across the entire code base. Reduce technical debt, prevent the accumulation of technical debt caused by architectural flaws. Improved maintainability, ensure the code base remains maintainable and evolvable over time. Faster code reviews, focus code reviews on functionality and logic, leaving architectural checks to the automated tests. Living documentation, architecture tests act as living documentation for the intended architecture of the system. They illustrate the rules and constraints that developers should follow. Developer onboarding, new developers can quickly understand the intended architecture by reviewing the architecture tests. What are architecture tests? Architecture tests are automated tests that verify the architectural design and dependencies of your application. They are not unit tests or integration tests, they are higher-level tests that focus on the structure and organization of your code. They typically involve defining architectural constraints, specifying the rules and constraints that your architecture must adhere to, example which layers can depend on which other layers. Analyzing code structure, analyzing the code base to identify dependencies, relationships, and other architectural characteristics. Asserting compliance, asserting that the code adheres to the defined architectural constraints. Tools for architecture testing. Several tools can help you implement architecture tests. Arch Unit, a free, simple, and extensible library for checking the architecture of Java systems, and Kotlin/Scala projects using Java-style bytecode. This is the tool demonstrated in the code examples below. Structure 101 *, a commercial tool for modeling and analyzing software architecture. SonarCube *, a popular code quality platform that includes architectural analysis capabilities. Custom scripts *, you can also create custom scripts using tools like static code analysis libraries, example Roslyn for C, to analyze and verify architectural constraints. ArchUnit, a practical example, Java. ArchUnit is a popular choice for Java projects, known for its ease of use and expressive API. Let's walk through an example demonstrating how to use ArchUnit to enforce a layered architecture. Scenario *. Imagine a simple e-commerce application with the following layers. *UI, user interface contains the user interface components, example controllers, views. *Application, application logic contains the core business logic and use cases. *Domain, domain model contains the domain entities and value objects. *Infrastructure, infrastructure contains the infrastructure components, example database access, external service integrations. We want to enforce the following architectural constraint. The UI layer can only depend on the application layer. The application layer can only depend on the domain and infrastructure layers. The domain layer should not depend on any other layer. The infrastructure layer should not depend on the UI or application layer, only the domain layer. Code example *. First, add the ArchUnit dependency to your pom.xml, Maven, or build.gradle file. Now, create an ArchUnit test class. Explanation *. 1 @ Analyze classes *. This annotation tells ArchUnit where to find the classes to analyze. You can specify packages, class files, or other sources. In this example, we use the packages starting with com-example.ecommerce. Using class file importer, the class files are directly read and analyzed. 2 @ ArchTest * marks a field as an ArchUnit test rule. ArchUnit will automatically discover and execute these rules during the test run. 3 Classes * this method creates a classes that object, which allows you to specify criteria for selecting classes to analyze. 4 That reside in a package * this filters the classes to include only those residing in the specified package. The notation indicates that all sub-packages are included. 5 Should only access classes that * this specifies the architectural constraint. The selected classes should only access classes that reside in the specified allowed packages. 6 Because * provides a reason for the rule, which is displayed in the test results if the rule is violated. This is incredibly useful for understanding why a rule failed and what needs to be fixed. 7 No classes should access classes that have simple name containing system.out. This enforces that no class directly uses system.out, promoting logging libraries instead. 8 No classes should use JavaTime because use java.time instead. This rule ensures that the project uses java.time, introduced in Java 8, instead of the legacy JavaTime library. This promotes the use of modern date and time APIs. 9 Imported classes, a static variable to hold the result of the class file importer. This is instantiated with the base package. How to run the tests *. Run the tests using your IDE's test runner or your build tool, example MVN test or Gradle test. ArchUnit will analyze your code and report any violations of the defined architectural rules. What happens when a test fails? When an Arch unit test fails, it will provide a detailed error message indicating asterisk the violated rule, asterisk the classes that violated the rule, asterisk the dependencies that caused the violation, asterisk the reason for the rule, the because clause. This information allows you to quickly identify the architectural issue and fix it. Example violation and resolution asterisk. Let's say you accidentally introduce a dependency from a class in the domain package to a class in the application package. When you run the Arch unit tests, the domain underscore should underscore not underscore access underscore any underscore other underscore layer rule will fail. The error message will tell you exactly which class in the domain package is depending on which class in the application package, allowing you to easily resolve the issue by removing the dependency or refactoring the code. Advanced Arch unit features asterisk. Asterisk custom predicates asterisk create custom predicates to define more complex architectural constraints. Asterisk ignoring violations asterisk temporarily ignore specific violations if necessary, example for legacy code. However, use this sparingly and document the reason for ignoring the violation. Asterisk descriptive naming asterisk use descriptive names for your rules to make them self-documenting. Asterisk integration with build tools asterisk integrate Arch unit into your CI/CD pipeline to automatically verify architectural constraints on every build. Best practices for architecture tests. Asterisk start early asterisk introduce architecture tests early in the project's life cycle to prevent architectural drift. Asterisk define clear rules asterisk define clear and concise architectural rules that are easy to understand and maintain. Asterisk keep tests up to date asterisk keep your architecture tests up to date as your architecture evolves. Asterisk prioritize rules asterisk prioritize the most important architectural constraints and focus on enforcing those first. Asterisk use descriptive messages asterisk use clear and descriptive error messages to help developers understand why a test failed and how to fix it. The because clause is your friend. Asterisk treat tests as first-class citizens asterisk treat architecture tests with the same level of care as unit tests and integration tests. Asterisk integrate with CI/CD asterisk integrate architecture tests into your CI/CD pipeline to automatically verify architectural constraints on every build. This prevents architectural violations from being merged into the main code base. Asterisk document the architecture asterisk architecture tests are a valuable form of living documentation. Use them to document the intended architecture of your system. Beyond layered architectures asterisk. While the layered architecture example is common, architecture tests can be applied to a wide range of architectural concerns, including asterisk solid principles asterisk verify adherence to solid principles, such as the single responsibility principle, SRP. Asterisk design patterns asterisk ensure that design patterns are implemented correctly and consistently. Asterisk naming conventions asterisk enforce naming conventions for classes, methods, and variables. Asterisk code style asterisk while primarily the domain of linters, you can create Arch unit rules to enforce certain code style aspects that impact architecture, example maximum method length. Asterisk security asterisk prevent the use of insecure APIs or patterns. Asterisk compliance asterisk enforce compliance with industry standards and regulations. Example, enforcing the single responsibility principle, SRP. You can use Arch unit to enforce the SRP by ensuring that classes have a limited number of dependencies and methods. For example, code example, no direct database access from UI. A critical architectural rule is to prevent the UI layer from directly accessing the database. This example demonstrates how to enforce this rule. Code example, limiting package cycles. Cyclic dependencies between packages can lead to tight coupling and make the system difficult to maintain. Arch Unit can detect cyclic dependencies. Integrating architecture tests into your workflow. 1. Add to build process ** include the architecture tests as part of your build process, Maven, Gradle, etc. This ensures they are run every time the code is built. 2. Continuous integration, CI integrate the architecture tests into your CI/CD pipeline. This will automatically run the tests on every commit, pull request, or merge. 3. Code reviews * refer to the architecture tests in your code reviews. Developers should be aware of the rules and constraints enforced by the tests. 4. Developer training * train developers on the importance of architecture tests and how to write and interpret them. Conclusion. Architecture tests are a powerful tool for improving code quality and ensuring adherence to architectural standards. By automating the verification of architectural constraints, you can catch architectural flaws early, reduce technical debt, and improve the maintainability of your code base. Integrate architecture tests into your development workflow to enhance your code reviews and build more robust and resilient software. Tools like Arch Unit make it easier than ever to implement and maintain these crucial tests. Start small, define clear rules, and continuously evolve your architecture tests as your project grows and changes. They will become an invaluable asset in safeguarding the structural integrity of your system. Architecture tests, fixing broken code reviews and promoting sustainable software. Code reviews are a cornerstone of healthy software development. They aim to catch errors, improve code quality, and share knowledge within a team. However, relying solely on manual code reviews can lead to several problems. Subjectivity and inconsistency * reviewers might have different standards and focus on different aspects of the code. Time-consuming and expensive * thorough reviews take time and effort, especially for large or complex changes. Overemphasis on style and minor issues * reviewers might spend too much time on formatting or naming conventions, neglecting deeper architectural problems. Delayed feedback * problems can be caught late in the development cycle, making them harder and more expensive to fix. Knowledge bottleneck * the burden of understanding the entire system architecture often falls on a few senior developers, limiting knowledge sharing. Architecture tests offer a powerful solution to these problems. They codify the architectural principles and constraints of your system, allowing you to automatically verify that the code base adheres to these rules. This empowers developers to catch architectural violations early, leading to more focused and productive code reviews. What are architecture tests? Architecture tests are automated checks that verify the design and structure of your software system. They don't test the functional behavior of the code, but rather its adherence to architectural principles like *layering * enforcing that different layers in your application, example presentation, business logic, data access, are properly isolated. Dependency management * restricting which modules or components can depend on each other. Naming conventions * enforcing consistent naming patterns for classes, methods, and variables. Interface segregation * verifying that classes implement the interfaces they are supposed to. Modularization * ensuring that the code is well modularized and dependencies between modules are kept to a minimum. Benefits of architecture tests * early detection of architectural violations * catch design flaws and deviations from the intended architecture early in the development process. Improved code quality and maintainability * enforce consistent coding standards and promote a clean and well-structured code base. Reduced code review burden * automate the detection of architectural issues, allowing reviewers to focus on more complex logic and functionality. Enhanced knowledge sharing. Explicitly define and document the architectural principles, making them accessible to all developers. Increased development speed. By catching errors early and promoting a consistent architecture, architecture tests can speed up the development process. Reduced technical debt. Prevent the accumulation of technical debt by enforcing architectural guidelines. Living documentation. Architecture tests serve as a living documentation of the architectural intent, making it easier to understand and maintain the system. Regression testing for architecture. As the code base evolves, architecture tests ensure that the architectural integrity is maintained. Tools and frameworks for architecture testing. Several tools and frameworks can be used to implement architecture tests. Arch Unit, Java. A popular library for defining and executing architecture tests in Java. It allows you to define rules using a Fluent API and verify them against your code base. Arch Unit NET, C/.NET. A .NET port of Arch Unit, providing similar functionality for C developers. DepTrack, PHP. A static analysis tool for PHP that helps you enforce architectural constraints. Schema Thesis, Python. Excellent for testing API schema conformance. Custom tools. You can also create your own architecture tests using scripting languages or static analysis tools. This might be necessary for specific architectural requirements or when existing tools don't meet your needs. Example, using Arch Unit, Java, for architecture testing. Let's illustrate how to use Arch Unit to implement architecture tests with a Java example. Consider a simple e-commerce application with the following layers. Presentation layer. Contains controllers and UI components. Service layer. Contains business logic and orchestrates interactions between other layers. Data access layer. Handles data persistence and retrieval. Domain layer. Contains core domain models. We want to enforce the following architectural rules. 1. The presentation layer should only depend on the service layer. 2. The service layer should only depend on the data access and domain layers. 3. The data access layer should only depend on the domain layer. 4. The domain layer should not depend on any other layers. Here's how you can implement these rules using Arch Unit. 1. Project Setup, Maven or Gradle. Add the Arch Unit dependency to your project. 2. Create architecture test class. Create a test class, example architecture tests.java. 3. Explanation of the code ****. At analyze classes, packages equals com example.ecommerce, ***. This annotation tells Arch Unit to analyze all classes within the com example.ecommerce package and its sub-packages. Important ***. Replace com example.ecommerce with the root package of your application. At Arch test static final Arch rule, this declares an architecture rule. Arch rule is the core type in Arch Unit. Static and final are best practices for Arch Unit rules. Classes, that, reside in a package, presentation. This defines the classes that the rule applies to. In this case, it targets classes in the presentation package or any of its sub-packages, example com example.ecommerce.presentation.controllers. The notation is used for wildcard matching of package names. Should, only depend on classes that, reside in any package, service, Java, JavaX. This defines the constraint. It specifies that the classes in the presentation layer should only depend on classes in the service layer or classes from the Java and JavaX standard libraries. Allowing Java and JavaX packages is important to avoid false positives, as these are often fundamental dependencies. No classes, that, reside in a package, module A. Should, depend on classes that, reside in a package, module B. This rule verifies that classes in module A should not depend on classes in module B, promoting modularity. 4. Running the tests. Run the architecture tests class as a JUnit test. If any of the rules are violated, the tests will fail, providing detailed error messages indicating which classes violate the rules. The error messages are usually very descriptive, pointing out the exact dependency causing the violation. Example of a failing test and how to fix it. Let's say a class in the presentation layer, product controller, accidentally imports a class from the data access layer, product repository. The presentation layer should only depend on service layer test would fail. The error message might look like this. To fix this, you would need to remove the direct dependency from product controller to product repository. The correct way to access data in the presentation layer would be through the service layer. Important considerations gradual adoption don't try to enforce all architectural rules at once. Start with a few key rules and gradually add more as the code base evolves. Team agreement ensure that the architectural rules are agreed upon by the entire development team. This will help to avoid conflicts and ensure that everyone understands the purpose of the tests. Contextual exceptions there might be situations where exceptions to the rules are necessary. Consider adding mechanisms to explicitly allow certain dependencies or violations, but document these exceptions clearly and use them sparingly. Unit allows you to exclude specific classes or packages from a rule. For example, integration with CI/CD integrate architecture tests into your CI/CD pipeline to ensure that every commit adheres to the architectural rules. Naming conventions establish clear naming conventions for packages, classes, and methods. This will make it easier to define and understand the architecture tests. Unit provides flexible ways to define rules based on naming patterns. Keep tests up to date as the application evolves, the architectural rules may need to be updated. Make sure to keep the architecture tests in sync with the current architecture. False positives be aware of potential false positives. Review failing tests carefully to ensure that they are not caused by incorrect configurations or incomplete analysis. Refactoring first before adding architecture tests, it might be beneficial to refactor the code to better align with the desired architecture. This can make the process of adding architecture tests easier and more effective. Beyond layering and dependencies architecture tests can be used to enforce a wide range of architectural principles, including immutability verifying that certain classes or objects are immutable. API contracts ensuring that API endpoints conform to a specific schema or contract. Exception handling enforcing consistent exception handling strategies. Logging requiring specific logging levels or patterns. Security preventing the use of insecure libraries or practices. Code example, ensuring immutable objects. In conclusion architecture tests are a powerful tool for improving code quality, reducing code review burden, and promoting sustainable software development. By codifying architectural principles and automatically verifying that the code base adheres to these rules, you can catch design flaws early, reduce technical debt, and ensure that your system remains maintainable over time. Start small, get team buy-in, and gradually expand your architecture test suite to reap the full benefits of this approach. They are an invaluable aid in preventing architecture drift and ensuring that your software remains true to its intended design. They are a worthwhile investment that will pay dividends in the long run.